Good morning, students. So we are continuing with the chapter Boolean Algebra, and in this video I'll be explaining to you about the canonical form, the SOP, POS, and conversion of SOP to POS and vice versa. Now in the previous video I briefly explained to you about the canonical form, that is SOP and POS, and in that video also I explained to you about what is min term, what is max term, okay, and shorthand notation. If you have not watched that video, go and check, first go through that video, okay. Understand the concept of min term and max term, and then only you'll be able to understand this. So before we start with the canonical term, let me first clear to what is Boolean function. Okay, we have seen this Boolean function in the previous video also, but here in detail I'll explain to you. Now a Boolean function is an algebraic representation. Alright, so it is an algebraic representation of Boolean expression which is composed of purely of min terms or max term. Now in the truth table, the binary variables that produce the output 0 is expressed as min term, and the binary variables that produce the output 1 is expressed as max term. Now however, in the Boolean function, alright, the output that is generated by the min term or the max term from the truth table, it can be expressed by ORing the min terms in terms of the min term where the function output is 1. Right, so where the function output is 1, the min term will be taken, or ending the max term where the Boolean function output is 0. So where it is 0, the max term will be obtained. Right, so this is said to be in a canonical form. So the Boolean functions can be simplified using the canonical forms to simplify the design of the digital circuits. Now keep in mind that all of these things is done to simplify the design of the digital circuits, right? So to minimize the complexity. Now, so what is canonical form? Now a canonical form is composed of either the sum of min terms or product of max terms. So the sum of min terms is also called as the sum of product, or the product of max term is called as the product of sum form. Right, so this is of two types. All right, so let's see one at a time. Now sum of product form. So SOP, as it is in short form, okay, SOP is a canonical expression that is entirely composed of min term. So this is entirely composed of min term. So a min term that is ORed, min terms that are ORed. So any Boolean function can be converted into sum of product form using the truth table, or it can be solved using algebraically. Right, so you can refer in the textbook. It can be solved in the two ways, both ways, using the truth table, or it can be solved using the algebraic expression. Right, so that in that case you have to use the different laws. Now the SOP is used to simplify the Boolean expression. So how do you obtain that? Right, so how is the SOP form obtained? Now by using the following steps. First, find the min terms from the table where the Boolean function output is 1. Right, so wherever the function output, Boolean function output is 1, take the min term of that. Then second, all the min terms that are obtained with the function 1, you OR it to obtain the simplified Boolean expression. So that output is the canonical SOP form. Right, so here is an example based on that. Here the Boolean function, okay, is equals to x complement y z, or okay, x y complement z complement, or x y z. So here you can see that this is ANDed, this is OR. So this is one min term, this is one min term, and this is one min term. Okay, so you can refer to the min term truth table in order to find the designation of these. That is the designation of this is 3, the designation of this is 4, and designation of this is 7. That is the decimal notation. So in this case, this is one min term, this is another min term, and this is another min term. So you can see that this is ORed. that is added. So this minterm is ORed with this, and this minterm is ORed together. Alright, so this is the minterm canonical expression or minterm SOP expression. Alright, so this is the canonical expression format. Now the canonical SOP form can also be further shown in terms of the designation or the notation. Right, so in terms of the notation, you can see that here f equals to, so this represents the sigma, okay, to represent the sum of product symbol sigma, and then here we are writing down the decimal designation, that is the index 347. So in the truth table, x complement y z represents 3. Right, so it can also be represented as the sum of the minterm notation, that is m3, m4, m7. So here this can be written in this format also, it can be written in this format also, so both are same. Right, so this is the minterm canonical expression or the canonical SOP form. So as you can see that this is reduced. Right, the algebra expression gets reduced to this. Okay, now using the truth table. So first, using the truth table, so the Boolean function output can be expressed using truth table by forming a minterm, alright, for each combination of variables which produces an output 1. So here you can see that here this is the example. Alright, so here you can see that 3 variables are there, so possible combination of the input variables is 8. Right, so here the function output, you can see that here wherever there is 1, you take the minterm of that. Right, so here as it says, by forming a minterm for each combination of variables which produce an output 1 in the function. So wherever the output of the function is 1, you form the minterm of that, that is this minterm. Right, and then excuse me, and taking OR of all the terms, then all the combination of the minterms you OR it. So in this case the answer is, here you can see that first you find the minterm of that where the function output is 1. So here you can see that in terms of the minterm, wherever the value of the literal is 0, you complement that. So 0, x becomes complemented, 0, y becomes complemented, so you get x complement, y complement, and z is 1, so it is not complemented. Right, so here also f is 1, so again here x is 0, so the literal gets complemented as per the minterm rules. Right, then y is 1, so y remains the same, z is 0, so z gets complemented. Okay, so similarly this, okay, and this also. So you have 4 functions with the output 1, so you have 4 minterms in total. Right, so in terms of the decimal designation, you can see that the numbering is here 1, 2, 4, and 7. Right, so we have to get that output. So now what we do is, the next step is we take the OR of the minterms and we can simplify the Boolean expression in this manner. So otherwise all of this will be considered as a Boolean expression. Right, so what we do is that where only the value of the function is 1, we take the minterm of that. So here you see that we AND the function value with the minterm, which is pretty much the same here, so we get the same value. Right, so this is the simplified Boolean expression or the canonical expression. Right, so the canonical SOP form can further be written in the symbolic form as sigma. Okay, and then the designation, decimal designation 1, 2, 4, and 7, or it can also be written as, okay, f x y z equals to, okay, m0 plus m2 plus m4 plus m7. So that is the sum of product form. Okay, Now, what is product of sum form? So a canonical expression composed of max term is called product of sum. So in this case, it will be completely max term. Now the Boolean function can be converted into POS form using truth table, or it can also be done algebraically. So the POS form can be obtained using the following steps. First, find the max terms from the truth table where the Boolean function output is 0. So in terms of min terms, where the Boolean function output is 1, you find the min terms. But in terms of max term from the truth table where the Boolean function output is 0, you take the max term of that. Then you add all those max terms obtained to obtain the simplified Boolean expression. So the output of that Boolean function is the canonical POS form. Alright, so here in this example you can see that here the literals are OR together, right? So this is one max term, this is another max term, this is another max term, so they are ended together here. So the ORing of this x plus y plus z is ended with this max term and this max term, right? So this actually represents one cell in the K-map, which we'll be discussing later on, right? Now the canonical POS form is the designation or notation of max term can be represented using the symbol pi, right? So in terms of min term we use the symbol sigma, and in terms of the POS we use the symbol pi. So here in terms of max term, this x plus y plus z would be represented in by the decimal designation 0, okay, and this is represented as 3 and this is represented as 5. So if you look at a truth table, you see that the designation is 3, 0, 3 and 5, right? That is in terms of max term where the output is 0, right? So it can also be represented by the max term designation, that is M, capital M, 0, M3 and M5, right? Now using the truth table also you can express it, okay. Now in this case, by forming a max term for each combination of variables which produce an output 0. So in terms of min term it was output 1, but in terms of max term output 0, and then you AND all those max term literals or the variables. All right, so here this is the answer, okay. So what you do is that where the function output is 0, you find the max term first. You find the max term, and since it is max term, so you OR the literals, okay. In terms of min term, you AND it, that is x dot y dot z complement like that. But in terms of max term, you OR the literals. Now in terms of max terms, if the value of the literal is 0, it remains the same, but in where the value of the literal is 1, it gets complemented. For min term, where the value of the literal is 0, it gets complemented, and where it is 1, it does not get complemented. But the opposite happens in max term. Where the value of the literal is 1, the input variable is 1, in that case the literal gets complemented. Alright, so likewise you have 4 function outputs with value 0, so all the max terms for those are found, okay. The designation is also, you can see here, okay. So this is 1, this is 2, 5 and 7, so we have to get that. So by taking the AND of all the max term, the ending of all the max term, we get this canonical POS expression. Alright, so the canonical POS form can be further written in this format, that is pi, okay. So this is the designation is 1, okay. It represents the decimal value 1. This represents 2, this represents 5, and this represents 7. So it gets further simplified using the canonical form. Okay, now conversion of SOP into POS and BOS to SOP. Okay, so here in this particular example it shows you how to convert SOP into POS. Similarly, for POS to SOP also it can be done. Right, so it states that, okay, the complement of a function a sum of mean term. All right, the sum, that means the sum of mean terms, that means here you see that sigma is represented for mean term. Okay, sum of mean term is equal to the sum of mean term missing from the original function, or vice versa. So SOP is represented by mean term and POS is represented as max term. All right, so here in this particular example you see that the function has three literals or three variables. So when you have three variables, that means three input values, how many possible rows can be formed? That is 2 to the power 3, right? So this 3 represents the number of literals or variables, so 2 to the power 3 forms 8 rows. So that starts from 0 to 7. Now in case of that, you can see that this function, in the case of this, the mean term has these 4 rows where the function value is 1. Okay, so here you can see that sigma 0 to 4 7, so that is the number of rows on the truth table. If you observe on the truth table, these are the rows where f equals to 1. Right, so there are 4 rows in the truth table where f equals to 1, that is the designation 0, 2, 4 and 7 in terms of the mean term designation. All right, so here according to this it says complement of a function. So we take the complement of this function, so f complement, okay, is equal to the sum of mean terms missing from the original function. So in this case, the sum of mean terms, right? So we take the sigma, that is the summation symbol, okay, the sigma of mean terms missing from the original function. So in this original function, these are the mean term values. So which are the remaining mean term values missing? So out of 0 to 7, we have 1 is missing, 3 is missing, 5 is missing and 6 is missing, right? So those missing mean terms are written here, which is equal to the, right? So this is equal to the sum of mean terms which is missing from this original function, right? So so when this is written in mean term notation, you can see that it will come out as m1, that is m1 plus m3 plus m5 plus m6, right? So this is in terms of the decimal designation, and this is in terms of the mean term, the shorthand notation more, right? So m1, m plus m3 plus m5 plus m6. Now according to the De Morgan's theorem, okay, we take the complement, further complement of f complement. So f complement, the whole complement, equals to this, the whole complement. Okay, so now taking each individual complement, so m1 complement plus m3 complement plus m5 complement plus m6 complement, okay, the complement, individual complement of that, okay, we get the is equal to the max term, is equal to the max term, so which is denoted by this capital M. Okay, so finally what we get is we convert the sigma to pi. Okay, we convert the sigma to pi, and then since this is represented as max term, capital M, and here how do we obtain is that we use the De Morgan's duality principle. Okay, so using the duality principle, what we do is that we change the complement to non-complemented. Okay, we change the literals and we change the symbols, that is the operators, from plus to multiplication, right? So that way we get the max term notation. So in terms of the decimal designation, we get pi 1, 3, 5 and 6. Okay, so here it is explained, that is the max term with subscript I, so that is the subscript I which is 1, 3, 5 and 6, is the complement of the mean term with the same subscript I, okay, mean term with the same subscript I, and vice versa. That is, if mi is the mean term for ith rows and mi is the max term for ith rows, then in this case, okay, mi complement, that is m1 complement, is equivalent to m1. Okay, so this way we can convert the SOP to POS, and then similarly we can also convert the POS to SOP. Okay, so yeah, students, you go through this video, okay, try to understand the canonical form, the SOP, POS, okay, and especially the conversion of SOP to POS, okay, and this format. Okay, so that will be all for today.